So she realized while she was a student that math really doesn't suck. Do you need help figuring out where you're going?
Yeah, I didn't know that I wasn't with the.
What letter group were you?
Hey, I was supposed to do it last time.
So you need to come to me during Gamma Block then, is all I care about. So
Okay.
you're going to come to me after lunch. Where did you go?
I went to language arts.
So then travel. So you can't go to math now. Do social studies now, because then we'll have you do math and then.
Okay.
Wait, you already did language arts?
Yeah.
Either go to social studies or science, but you may have already missed the intro in science, so I'd probably say go to social studies.
Okay, that's cool.
Yeah, you got to pay attention to the Friday schedule, man. Yeah. All right, so we do have homework, 5-1 worksheet. It's up here and it's up there. So plain book, assuming 8th graders still actually use plain books. But Danica McCuller's sweet. She wrote these math books, and we just got them in per my request because Miss Rosie's always like, we have money. What books do we want to buy? And they're really well-written books. She has a really great sense of humor, and I like authors that have a great sense of humor. So her first one that she ever wrote was Math Doesn't Suck. But being that you guys are in the Math 2 class, I doubt that you really think that math sucks. So the ones that you would probably be more interested in was Hot X, Algebra Exposed. And these are all like interesting reads, but they also like make your math skills, they improve your math skills. Kiss My Math is just another like random like mathy type book. And then Girls Get Curves is all about geometry. So because she is a female author, she is writing from the female perspective. That does not mean that these books are only for females. That just means that's the perspective she writes from. And most of the time, if we're going to talk stereotypical male versus female, females will claim that they're bad at math. And they think they can get away with that because, oh, I'm a girl, I'm bad at math. No, that's not true. Some of the best mathematicians were females. So none of this whole because I'm a girl, I'm bad at math. Danica McCullough, living, breathing proof. She was a child actress, didn't need to be good at math, wrote math books. So very passionate. I love her stuff. I have these in my room, but if you want to check them out, you just get it from me and go write it down on the checkout slip in the library because Miss Rosie figured that I would probably more easily connect kids with those books than she would since I'm the math guy. So, with all that being said, we get to dive into actual work today. Woo! But with there being homework today, one, my goal is always that we have time at the end of class to work on your homework, and two, it's not due till Tuesday. I always give you 2 business days to get things done. Business days are days in which you are at work, Monday through Friday, unless it's a holiday. So you have today to work on our homework, and tomorrow. Now hold up, I don't actually want to give these out yet. If we look at this sequence, or this like series of shapes, see my triangle, it has 60, 60, 60, and these are all regular polygons, obviously, because they have congruent interior angles. Do we see a pattern happening here? Can we identify anything? So 60, 60, 60, I see 180. 90, 90, 90, 90, what do I get there? 360. 108, 108, 108, 108, 108. 540. Do I see any pattern? Calvin? For each angle added, you add 180 degrees. Now, a lot of what we do this year is trying to figure out any way that we can write out a pattern in sort of like a formula or something like that. So, would there be a way to talk about adding 180 degrees for each angle in a way that we could write it as a formula? So, could I just write 180 degrees times the number of angles? Does that work?
Because you have a triangle, and that is 3.
So the triangle has 3, and it's not 3 times 180. It would actually be what times 180? 1, right? So instead of using n, what do I need to use, Brian?
N
n
minus 2.
minus 2, which is where we derive our angle or our polygon angle sum theorem. So anyone know what the definition of a theorem actually is? Because people are like, well, what's the difference between a theorem and a hypothesis or a fact or a rule or a law or a like what is a theorem? Why do we talk about theorems in mathematics? It's okay that you guys don't know. I didn't really expect you guys to know. Carmen?
Maybe something to like make it easier, like kind of like a little trick.
Yeah, I mean, so theorems do make things easier. They're kind of like tricks or. So I agree with what you said. They do make things easier. They're like rules that we can use. but how does it get called a theorem? Like, at what point do I get to call something a theorem? Like, when do I get to switch from, hey, this is what I think, to, hey, this is now a theorem? Calvin?
It can be proved.
It can be proved. And so with it being proved, it also can't be disproved, at least with the math that we know right now, which is interesting if you paid attention to anything about the gravity waves. Pretty much everything that we know in physics has kind of been like validated based off the fact that we saw a change in gravitational waves. It was the first time we were able to
Wasn't there
detect.
about they had this giant lab, they
Yep.
had 2 lasers set up, and they actually saw a little bit of a distortion
Yep.
at a certain point.
So that happened March, I want to say, of this year. But if you're curious about it, go look it up. But so a theorem is a generally agreed upon rule or statement or proof or formula or something for mathematics that can be used to solve problems. So it's generally agreed upon and can't be disproved. So we can't call it like a law or a fact because we aren't 100% certain that it will work in every single situation. But for what we know, for the mathematics or the science that we are aware of, it works. So a theorem is generally agreed upon. It works in every situation that we're aware of. Now, if we went to a different planet and their physics operated differently, our theorems that work on Earth would maybe not work there. So that's why they're called theorems as opposed to anything else. Our learning target. I can apply the correct formula to determine the sum of the interior angles of any polygon. And just like that, I can then find one of the angles, assuming it's a regular polygon, and use that to find the exterior angle, just like right here. We see that all interior and exterior angle pairs will add up to 180, and we already know those rules. So let's dive in. Then the first thing you see on your notes are the 3 important, they're called take notes on there, but they are the 3 things that are most important to our lesson. So we have our sum formula. We also then take the converse or the corollary to that. Corollary means it's related to, but it's like a manipulation of. So the corollary says that each interior angle, so you might want to highlight that one of these is actually solving for the sum, and the other one is solving for the interior angle. Then the exterior angle sum, this is actually really, really cool. The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. So if you think about that, what they're saying is, if in any regular polygon I sum together my exterior angles, it's gonna equal 360. And we're gonna look at some proofs later of why that happens, but this is really, really cool, because you could have a 100 gon, and you have 100 exterior angles. What would each of those exterior angles need to measure, assuming that it's a regular 100 gon? That would be the sum of them. Yeah, 3.6. We can, just like that, figure it out.
Oh, wait, that means you know
Interior.
Every interior angle then would be the supplement to your 3.6. That easy. So these are like the weird thoughts that I think of either late at night or early in the morning or whatever, and then I'm like, should I really say these things out loud? So you know how everyone always talks about like your brain exploded or your head exploded or like whatever. Oh, it finally captured, but of course I had that open. So I want to like rig, and this won't ever really happen, but I want to rig one of those like confetti cannon things, whatever, so that like on cue I could like literally. I thought that would be funny. And if nobody knew about it, like imagine if I did that in a 7th grade class and no one was aware it was going to happen. It'd be pretty sweet.
Somebody would scream.
So here's how we apply this. We use this, and n is the number of sides of your polygon. So if we have a heptagon, this is where words get really fun. Heptagon is how many sides? 7. So we go ahead and use 7 subbing in for our n value. So a lot of times with our notes, I show you one problem completely solved out, because as we get further into the year, these problems are really complicated. So when you go to do your homework, reference back to our solved out problems, and then the got it is where you practice and apply it on your own. So we've got our formula here, and we're starting the year, so yeah, you guys might be thinking all we're doing is subbing and solving. We start easy, and trust me, we're going to ramp up and get a lot harder. So if it's a 17 gon, again, apply your same formula. The sum will be that 17 gon minus 2 times 180. So 17 minus 2 gives me 15 times 180. What is 15 times 180? Anyone verify that for me? 2,700? Yeah?
Same here, Caleb.
And then quickly, if I asked you for one interior angle, well, if this is the sum of the interior angles, how could I find one interior angle? Ryan? Just divide by 17. So if I wanted to find one interior angle, 2,700 divided by 17, and I'd have it. That easy, because we know how many interior angles there will be. Then I could find the supplement to find its exterior angle. Any questions on how we did that?
Yeah.
What would it be? 4? What?
Oh,
158?
Yeah.
So close to 160.
technically 159 rounded.
What do we know about as the polygon gets more and more sides? The interior angles. Yeah, they get closer and closer to 180, right? But they'll never actually reach that, because if you have like 1,000 gon or a 10,000 gon, it's going to end up looking like a circle, but it's not. Like, think about a golf ball. It's circular, but it's not actually a sphere. It's got a bunch of dimples and flat edges. So if you think about that, that's actually, I forget the name of three-dimensional polygon. Polyhedron? Yeah, polyhedron. So it's actually a polyhedron. If those dimples were flat, I think it'd be even sweeter. Do you guys know why a golf ball has dimples?
It's the aerodynamic.
That, and so when you hit it with the club, it squares up on one dimple, and it flies the direction you want it to. So if your club face is angled, it'll square up at that angle. If your club face is square, it'll square at the straight.
So wait,
But then the spin of the ball also determines what it does.
we haven't like this is just a question. If you change the angle, which like let's say there's two dimples right next to each other, and you get one or together, will it actually like drastically change the
So
direction?
during the impact, in that moment of impact, the ball would actually slightly change its direction to match your club face, and then before it bounces off.
Alright.
Because you act like, if you slow-mo watch a golf shot, there's like an amount of time where they move together, and then the force goes from the club into the ball, and then it leaves the club face. It's really sweet.
Have you ever seen
Yeah,
a
where
picture
the
like
ball
where
like
it hits
flattens out.
Yeah.
And then
Have you ever, well, this is different, but also it's the same effect that happens to a golf ball. If you take a basketball or something, I forget who, I have them on my YouTube channel, I'm subscribed to them, but they go up on top of a dam and they take a ball and they drop the basketball, and of course it hits the dam or whatever, or then they toss it like this. It flies way out to the river because the curve of the ball. It's sweet. Yeah, check it out if you want to. So now we're given common housefly, a Musca domestica, has eyes that consist of approximately 4,000 facets. So this is why flies are so hard to kill. They look at many different angles. So this common housefly literally looks at 4,000 different angles at the same time. Interesting fact, before a fly can actually fly, it jumps. So if you ever want to kill a fly, come from directly above it, you have the best chance of getting it.
Wait, how can a fly's brain process 4,000
Yeah.
angles of view?
I don't know, but it does.
Does that mean they're smarter?
That's like the fact that fish eyes don't connect. Like our eyes like see one image, fish eyes look two different directions, and their nose comes out in front of them.
isn't that the same like with turtles?
Maybe.
Well, like their eyes are on like different
Yeah.
sides of their heads.
So each facet is a regular hexagon because hexagons tessellate well. What is the measure of each interior angle of one hexagonal facet? So the measure of one angle, we have our formula here, which essentially we take the sum and divide by how many angles there are. Pretty easy formula. So first we figure out the sum of the angles. So what's the sum of the angles? 720. And you get 120, right? Nonagon. What would a nonagon be? Yeah, 9, right? Octagon, nonagon, decagon. Anyone want to do it? Can you come do it? I can do the math for you, or did you already do the math? I need to turn off my Schoology updates. $12.60. I got you. 140. And you're done. Yeah. So then if the question extended to say what then is the measure of the exterior angle, by the way, make sure you're always labeling with degrees. So the exterior angle would then be
40.
just 40 degrees. Of course, it is the supplement. Which ties back when we first start learning about supplementary angles, and you're like, well, why do we care about this? Not necessarily you, but the general middle school student. It all ties back in. It is very important, especially if you want to go into engineering or architecture or anything like that. Ooh, talking about tessellations too, by the way. How is a soccer ball made? What shapes are tessellated there?
Oh, pentagons and hexagons.
Pentagons and hexagons. Because to do the three-dimensional, it has to have both shapes. It's really cool. So, measure of angle G. Now, notice that these formulas that we have, do they say they only work on regular polygons? No. Because any polygon that has the same amount of sides, even if we change and manipulate it, have you guys worked in Geogebra at all? Did Mr. Hall show you that last year at all? So Geogebra is a really sweet program. How long do I have today? I've got long enough. So I'm going to show it to you really quick. We're not going to do much. And I would have you get your homework first, but I want everyone to actually pay attention. Geogebra.
I think you showed it to us. You gave us like a packet. Some of us didn't have anything.
Yeah, because I had you guys for a day. And I like the goal was to model a specific something. So if you go to geo, like geometry, gebra, like algebra, this website's amazing. Tons of stuff you can do, but I like to just start GeoGebra. It is a Google app, so you do not even need to download anything. Notice now it is through the App Store. So you can go to all these different areas, but what we would do is geometry. You can make anything you want. Polygons, regular polygons, rigid polygons, vector polygons, all these different things. So if I do this, I'm just going to start connecting points and making a polygon. And then I can actually have it tell me what the angles are. So if I want to know what's the size of this angle, and I think you have to go no, you have to go clockwise. I always do that wrong the first time. So I want to know my angle size. Boom, boom, boom. It tells me my angle size. But then as I move any points, it adapts as I move.
Oh, so you can actually model a polygon with the...
It's a live geometry modeling tool. And then I can turn on like grid lines. So there's all kinds of stuff that you can do in here. If you get bored, play around in GeoGebra. It is quite a fun program. And there's also, if you YouTube GeoGebra, there's like people doing like, oh, if you want to do a smiley face, or if you want to do this. So pretty sweet program. That and Desmos. Desmos is that free graphing calculator website. Those are two websites that you should probably have as shortcuts on your browsers. So, sorry, all of that to come back to, what type of polygon is this?
Quadrilateral.
Yeah, it tells me quadrilateral. What will be the sum of the measures of a quadrilateral? 540, right? So, nobody?
Wait, oh, you want to start?
I'm waiting for him to.
Think of a square. Quadrilateral.
That's right.
Your 540 is not
Yes,
a quadrilateral. Yeah, so 360. So this,
I thought you were saying he was right, and I was like, my bad.
I was going to move on until I heard somebody say, like, but they didn't say it loud. They were like, wait. Yeah, I heard somebody, because I will move on with a mistake to let it percolate through the problem. Like, I love that word. I've started using that a lot. So coffee used to be made with percolators, and actually I still, when I go camping, I have a percolator. It makes water go up and then go through the coffee grounds and come down, and then you make coffee. And then, like, the coffee is your answer, right? So percolating through something is like working through a problem. If we did this with 540, we would have gotten a very wrong answer, and then we would have figured out that our answer was very wrong because it would not have made sense in the problem. So I know that this will sum to 540. I can say that 120, not 540, 360. I can add these up. Then what do I need to do? Yeah, so I'm just going to say plus G equals 360, and I solve this like a simple equation. I sum my angles over here. Well, 120 and 85 is 205, plus 53 more is 258. Yeah, sorry, sometimes my G's turn into 6's when I'm writing too fast. What is it? 102. In the context of this problem, and with how it looks, would it make sense for that angle to be 102 degrees? Yes. Now, if we had done that with 540, we would have gotten an answer that was 180 more than that, so we would have gotten an answer of 282. So if we had plugged in 282 here, that would have been, like, obviously wrong, right? You can't have an obtuse angle like that. That's not even, at that point, angle classification is kind of out the window, because once you go over 180, it's not really classified anymore. Very good. And if you, instead of writing M angle, my shorthand for that is just the angle symbol with the arc through it. That is representing how big the angle is. So you can either write M angle, so that's measure of angle G, or that symbol G equals 102. So I'll capture that so that we have both options shown. By the way, on Monday, somebody make me do our Schoology page. I was going to do it today, but I realized it's not that important yet. But I want to get you guys logged into my Schoology page, and it's not the district one. Like I might use the district one. Clear. I just need to copy it all over. But I just need to give you guys your code and everything. And then I upload PDFs and videos and all of that.
So is that why you're recording this now?
Yeah. So it'll obviously, so like if you're sick someday. But what I'm struggling with now is my uploader won't work here. So I have to take the video home and then upload it. So there's some delay in like getting it online. So now we want to find what is each exterior angle. And this is where our exterior angle sum is super convenient. Because I see that this is an octagon. But regardless of what size of polygon it is, my exterior angle is summed to 360. So as different from interior angles, where interior you have to figure out what the sum is, here I already know, we just divide by the amount of angles, we get our answer. So if we want the exterior angle of a nonagon, what would we divide 360 by? 9. And what is 36 divided by 9? 40. So we get 40 degrees for each exterior angle. It is that easy. Are there any questions, comments, or concerns? This is why many days we will be covering multiple lessons in one day, but being that it's Friday and I'm giving you homework, I figured it would be a good thing to give you 20 minutes to work on this, and you can probably get done, some of you.
Yes!
Wait, I have a question.
Yeah.
Do you care about the organize our binders?
As long as I could make sense of it, it needs to be in some type of organization. I don't care if you go new to old or old to new, notes in one section and homework in another. I don't care how you do it as long as you could explain it to me. I do collect all of the homeworks on the day of the mastery.
Okay,
So,
you're like Mr. Holmes.
yeah, so then if you do poorly on the mastery, I can refer back to your homeworks and say, well, you really didn't put much effort into your practice work. This is why you got to progress in. Go back and redo the practice, or I'll give you some other practice forms, and then try the mastery again, or a different mastery or something like that.
We're in class today.
Yes, but today, like,
Or well,
so it's,
I know not today. I was
yeah,
just saying
it's
like
awkward on Friday because the whole schedule.
And then we have to remember what class we're in and say
Yeah.
everything's
Literally, my math schedule on Friday flips it, like turns itself completely around.
When, Mr. Hudson, for this first one, do you use, it says to start determine the sum of the angles using the Polygon angle sum theory. Do we just use the one to the left of it?
Yes. Yeah.